Today we'll discuss lesson 16 of class 11. In today's lesson, we will derive the following equations of motion for a uniformly accelerated motion from the velocity time graph. So in this lesson, we will derive the three equations of motion, starting with v equals to u plus at using your velocity time graph. So before we start, we have to understand what is a velocity time graph. So velocity time graph means you have two axes. You have your x-axis and you have your y-axis. In x-axis we record our time, and in y-axis we record our velocity. Suppose, let us say, at time t equals to 0, a particle is or a car is moving with a velocity v0. Initially it is moving with a velocity v0. Now after some time the particle moves to the point P. After some time t1, at t equals to t1, the particle has moved towards the point P and it has increased its velocity from v0 to v1. Fine. So initially the particle had a velocity v0. After some time, let us say this time, the particle has increased its velocity v1, and we represent this one at this point. This one represents your v1 and this one represents your time t1, which is represented by a point P. Fine. Now again your particle moves for some more time. Let us say it moves from time t1 to t2, and again it increases its velocity from v1 to v2. So it reaches from point P to Q in such a manner that it, after some time, let us say after certain time, earlier it was at t1, now the time has passed and the time now is t2, and the particle velocity earlier at t1 was v1. Now at time t2 the particle's velocity is v2. So we will denote this point as point Q. Fine. So this is your velocity time graph. Now in this time graph we will look what does this slope PQ represents. So the slope of the velocity time graph, this is your slope of the velocity time graph, which is PQ, or I can say also as AB. This slope, what does the slope represents? So let us consider the small fragment of this slope P and Q. So what is this slope? This slope generally represents your change in the y-axis divided by your change in the x-axis. That means change in the y-axis divided by your change in the x-axis. Fine. So the change in the y-axis is represented by QR. This change, earlier it was V1, now it is V2. So this change is represented by QR, and change in the x-axis is represented by your PR. Earlier it was time t1, now it is time t2. So this change is represented by PR. So what is my QR? QR is V2 minus V1. V2 minus V1. And what is this PR? PR is T2 minus T1. T2 minus T1. Now what is V2 minus V1? V2 minus V1 is change in the velocity. What is T2 minus T1? It is the time interval. Fine. And we know the change in velocity divided by time interval is my acceleration. So this slope PQ, or I can say this slope AB, what does this represent? This represents the acceleration of the body or car or object. Fine. So this slope represents your acceleration. Now we will use this slope to derive our first equation, V equals to U plus AT. Now let us consider a similar case. Suppose at time t equals to 0, the particle is at point A, which is moving with the initial velocity u. Fine. Now after some time t, what happens? The particle has increased its velocity till v. So it is denoted by a point B. From it was earlier in the case A, but time t equals to 0 and your velocity is u. Now it is in the point B where time t equals to t and velocity equals to v. So this is your velocity time graph. Now what does this slope represents? This slope represents your acceleration of the particle or the body. So acceleration equals to slope of the velocity time graph AB. Now we know what is the slope. It is change in the y-axis dB divided by change in the x-axis AD. Fine. Now AD and OE are of same length. So instead of AD, I can write OE. Instead of AD, I have written OE. So dB by OE. Now dB, I can also write it as this whole length EB minus this small length ED, which will give me dB. So I can write it as EB minus ED divided by OE. Now what is EB? What does this EB represents? EB represents, what does this whole thing represents? It represents your final velocity V. So I've written final velocity V. What does your ED represents? This line. What does this ED represents? ED represents your initial velocity U. So I have written small u. And what does your OE represents? OE represents your time. OE is your time. So I have V minus U by T, or I can say A equals to V minus U by T. Send this T here. So I can also write this one as V minus U equals to AT, or I can send this term to the other side. So minus will become plus. So I have V equals to U plus AT. So I have derived my first kinematic equation. Now let's move to the next one. Next we will derive S equals to UT plus half AT square. So now we have learned that your slope represents your acceleration. Now what does the area under the slope represents? Fine. So next we will study area under the velocity time graph AB. So this is your shaded area. We will see what does this shaded area represents. Now this shaded area represents u of a trapezium. Trapezium OABD. And we know what we have to do. We have to find out the area of this trapezium. To find out the area of this shaded area, I have to find out the area of the trapezium. And what is the area of trapezium? Area of trapezium equals to half of parallel sides, or I can say half of sum of parallel sides into the height. Now if this one and this one represents your parallel side, so half of OA plus BD, sum of parallel sides, times the height of the trapezium. It is represented by this one, OD. So OA plus BD times OD. Fine. Now what does this OA represents? OA represents your initial velocity V0. So OA I have written V0. And what does your BD? This one represents BD or I can say what does this one represents? This one represents your final velocity v. So I have written instead of bd small v. Fine. Now what does this OD represents? OD represents your time interval, that is t minus 0. Here the time is 0, so t minus 0. This is t minus 0, which will be simply t. Fine. Now we know half of sum of the velocities is your average velocity, and this one is your time interval. So average velocity equals to the distance covered, the distance covered by your time, or if they have given average velocity times your time, like in this case, what does it will give? It will give us the distance traveled by the body in time t. Fine. So the area under, or area under this curve, or your shaded area, this area, what this represents? It represents the total distance traveled by the body. Fine. So now we will derive our equation s equals to ut plus half at square. Acceleration equals to dv by ad. Acceleration equals to change in y-axis dv, change in y-axis ad. dv by ad. ad represents your time t. So dv I can write as at. Fine. Now I have to find out the distance traveled by the object in time t. So what I have to do? I have to find out the area of this shaded region. Again, this shaded region represents your trapezium OABE. So the distance traveled equals to area of the trapezium OABE. Now this trapezium has two geometrical shapes. One is your rectangle OADE, another one is your triangle ABD. Fine. So let's make it simpler and let's area of this rectangle first. Fine. So area of this OADE. Area of rectangle equals to the length OA times the breadth OE. OA times OE. Next, area of triangle. Area of triangle equals to half of the base dB, or I'll say half times the height. Height is your dB times the base of the triangle AD. Half of dB times. So what does your OA represents? OA represents your u. What does this OE represents? OE represents your time t. So OA times OE equals to ut. Next, what does your dB represents? dB. dB dB is 80. So I have written 80. And what does your 80 represents? This represents your time. So I have ut plus half 80 times t, and 80 times t, what will happen? It will give me t. Distance traveled by the object in time t equals to s equals to ut plus half at square. Fine. Now let's move to our final equation. V square minus u square equals to twice of as. Now again consider your velocity time graph. Now what will be the distance traveled? It will be the velocity under this time curve, or I can say the area of this trapezium. Fine. So the distance traveled equals to area of the trapezium OABE. Again, the sum of the area of the trapezium is half of sum of the parallel sides EB times OA EB plus OA into the height of the trapezium OE. OE represents your height. So half of EB times ED. Instead of AD, I can write OE. Why OE? Because this represents your time. So I've written OE. Fine. Next, what is the acceleration? Acceleration is this slope of the time curve AB. And acceleration, how do you denote? Change in the y-axis dB divided by your change in the x-axis AD. And your dB can be written as EB minus ED. EB minus ED. So this represents your dB. Fine. Next, instead of AD, I can write OE because they are of same length. So I have written OE. On simplifying further, that means I can send this OE here and this A to the denominator. So I can write OE equals to EB minus AD divided by A. Fine. Now, coming to our this equation, distance traveled in time t equals to S equals to half of EB plus ED times OE. And here we have derived what is OE. OE is EB minus ED by A. EB minus ED by A. Fine. Now, here I can use my equation A plus B and A minus B. What is A plus B and A minus B? It will give us A square minus B square. Or I can say EB square minus ED square. Fine. And this 2 and A gets multiplied in the denominator. So I have 1 by 2A in the bracket EB square minus ED square. Now, what does my EB represents? EB represents my final velocity B. What does this ED represents? ED represents my initial velocity U. So instead of EB and ED, I can simply write V square minus U square. Fine. Now what I will do, I will send this to A on the other side of the equation. I'll multiply with it S. Therefore, I can write V square minus U square equals to twice of AS. Fine. So this is my third kinematic equation. Okay. So if you have any confusion with any of these three kinematic equation or with the graph, please do ask. I will re-explain it to you again. Fine. So that's it for today's class. Thank you.